Merkava is one of the most unique modern tanks. That's a fact. Fact front. The vehicle, which began service back in '79, is primarily distinguished by its front-mounted engine layout. As a result, this Israeli chariot has a host of nuances and problems when it comes to protection, which I've already detailed in my past video. If you haven't seen it, make sure to check it out. I left a link in the description and hints at the top of the screen. However, armor and protection aren't the only important aspects influenced by the unusual design. Today, we'll cover equally important combat readiness criteria: mobility. How good is the Merkava on the move, and what might surprise or disappoint its competitors? Enjoy the video! Originally, the Merkava Mk1 had an American engine from the M60, as well as the M68 gun, gearbox, and many other electronics and systems components. However, even at 900 horsepower for 56 tons, the power wasn't particularly enough. Of course, the power unit was also in the front, and as I mentioned earlier, because of this, it was unrealistic to use a full-fledged combi, and not just due to lack of space. The point is, it would further shift the center of gravity forward, increasing the weight of the already overloaded front end. In general, it's worth noting that when creating the Merkava, the Israelis were inspired by the American prototype light tank T-92, developed in 1956. It also had a front engine, rear door, and a very compact turret, the center of rotation of which was significantly moved back to compensate for the weight of the engine and frontal armor. This allowed for an even load distribution on all the support rollers. However, in the Merkava, this was sacrificed to create a larger troop compartment. Despite the tank being 3 times heavier and twice as long as the T-92, the turret ring was traditionally placed in the center of the chassis, which didn't allow balancing the turret weight with the front-loaded weight. As a result, the Merkava's center of gravity shifted significantly forward, which was reflected in the uneven placement of the support rollers along the longitudinal plane. Ignoring all the primary principles, they had to resort to resorting to the use of crutches. Also, the Merkava has become the widest tank in the world at a full 4 meters. Again, thanks to its engine, which sits parallel to the driver in their armored capsule. They couldn't place it behind the engine either. That would have taken up space in the rear section, and in that case, the driver wouldn't have had any visibility at all. By the way, the Israelis learned this from the Soviet BMP, where the driver also had to be placed next to the engine. The Merkava's engine evolved from 908 horsepower in the first version, 950 horsepower in the second, 1200 horsepower in the third, and finally 1500 horsepower in the Mk4. As the weight increased, surprisingly, so did its dynamic qualities. Debates about the Merkava's weight have raged on the internet for decades. In short, it varies in different sources from 63 to 82 tons. In the Book of Memory by Ihyam Harpas, it says that the weight of the Israeli machine quickly grew from 45 to 60 tons, and when it reached 65, this information was suddenly declared a state secret. For the Mk3, the weight mentioned was 70 tons. More precisely, it says that the suspension developed for the Mk3 allows a 70-ton platform to move quickly over heavily rugged rocky terrain. Recently, a video was posted on YouTube about the Mk4 crew, where the driver said the tank weighs 80 tons. Israeli military analyst Yoav Saitun went even further and indicated the modern machine's weight is around 82 tons. He was guided by the fact that installing the active protection system adds at least 1 ton, considering the installation of 4th generation door dalet armor and the newly created removable belly armor put on only before combat operations in mine-threatened areas. This means that ordinary Merkavas go into battle without it, and that's a good clarification modification to our previous episode. Overall, numbers over 70 tons seem a bit exaggerated. Nevertheless, they repeatedly appear in open sources. The first Merkavas were equipped with various modifications of V-shaped American diesel engines by Teledyne Continental, with air cooling, an injector fuel system, and turbocharging, assisted by the American Ellison CD850 transmission. Major changes occurred with the MK4. They've installed the latest German automatic transmission, Range RK3225, with 5 gears for both forward and backward driving, and a hydraulic steering mechanism. The weight of this unit without lubrication is 2,350 kilograms. They are manufactured by the company Ashot Ashkelon under the Reng license. Continued, it is integrated into a single block with a licensed German water-cooled engine, JD883, by American General Dynamics. This is a copy of the German MTU883. By the way, in case of a breakdown, the engine transmission unit can be replaced with a new one in just a couple of hours. All you need is to open the front engine compartment and remove it. Turn the turret to the right and also remove the armor modules on the left side. Then you can extract the engine module itself. And you'll definitely need a good lifting crane, considering the total weight of the unit is a hefty 4,150 kilograms. Even the power unit of the Abrams is lighter, and the T90, with an engine weighing around a ton and transmission about 800 kilograms, also requires lifting. But overall, the Merkava unit is built in the finest traditions of the Western school. Everything here is top of the line. The engine's displacement is 27.4 liters. Weight is 1800 kilograms. Both figures are less than those of the Teledyne Continental, hinting at a smaller footprint, I'll say. Think about it, the JD883, having power equivalent to the Leopard 2, requires only 60% of the volume needed for the installation of the MTU873K501 from the same Leopard. So, the 883 is considered one of the most successful Western diesel engines of its class. Beside the Merkava 4, it was also used in the first series of South Korea's K2 Black Panther, the French Leclerc sold to the United Arab Emirates, the so-called Tropical Leclerc, and in the export version of the Challenger 2E. Germans sure know how to make things, and this engine is no exception. It boasts improved mass dimensional characteristics and better power-to-weight ratios, as well as high fuel efficiency. Increasing its liter power required improvement to the turbocharging system with incoming air cooling, as well as increased efficiency of the liquid cooling and the intensification of piston oil cooling. Individual fuel pumps with an electro-hydraulic fuel supply control system were introduced into the fuel system, and thanks to the use of a specially designed oil pan and an additional flat oil tank connected with it, operation is ensured at any inclination or pitches. The power unit is controlled by a computer that provides all necessary information to the driver. This shouldn't be surprising, given that even the old connection with the Ellison transmission was already controlled by an electronic unit, into which numerous improvements to working algorithms were introduced over the decades. In short, the power unit is definitely a strong point of the Merkava. 1,500 horses give the car very good dynamics, even for its weight. The question remains, how much does the Merkava actually weigh? If we start from 65 tons, then it's 23.07 horses per ton. If 68, then it will be 22.05 per ton. 75 tons, that's 20 horses. In the worst case, with a weight of 82 tons, it will be 18.3 horses per ton, which is still at the level of machines like the Challenger 2 and the T-72B. Overall, if we average it out, it's not bad. The Merkava accelerates to 32 km per hour in 7.6 seconds, which also commands respect. An acceptable maximum is 64 km per hour, so even if compared to the same T90M, in general, we have equivalent values. Especially considering that according to recently leaked technical documents, the full mass of the T90M is also 52 tons. not 48 as previously reported. Thus, the specific power index of the Russian tank fell from 23.5 to 22.16 horsepower. The difference with the Merkava is roughly 2 horses per ton. But this is all on paper and on good solid surfaces. In practice, I am somehow still convinced that the T-90M's combat mobility will indeed be higher. After all, engineers' jokes with enormous masses have never yet led to anything good. Of course, this manifests itself in high specific ground pressure. The width of the Mk4 tracks is 660 mm. The length of the support surface is 4520 mm. From this, we can calculate our interesting index. Strangely enough, we will have it in different versions since we do not know the exact weight of the Israeli machine. The values at different mass variations you see on the screen, but overall, if you take the average, it turns out that the specific ground pressure of the Mk4 is 1.21 kilograms per square centimeter. This is the highest indicator among all known tanks. Partially for this reason, the Merkava is not sold for export. With its unbalanced weight distribution, large mass, and overloaded front, it would bog down in uncertain terrains more than the British Challenger 2 successfully does today in the muddy steppes of Ukraine. After all, the Merkava is purely a regional vehicle, designed exclusively for the specific conditions of the local theater of operations. The fact is, most of the soils in the Middle East, despite a layer of sand or clay, are underlaid with solid rock, allowing a tank with a high ground pressure to move without much difficulty. This is due to one simple fact. In soft or loose ground, the tracks dig down to the bedrock, giving the tank traction and making it possible for it to move. However, this trick is unlikely to work anywhere else. Do you really think the Israelis wouldn't sell something that sells well if there was demand for it? Neither in Malaysia, nor in India, nor in South America is this tank useful. Moreover, the Merkava Mk4 engine only runs on diesel, whereas the V92 engine in the T90M is multi-fuel, which is a clear advantage in wartime. But the Merkava, unlike the 90s, has an excellent reverse gear. The Israelis equipped their chariot with a reversible transmission, so in theory, their tanks can move forward and backward at the same speed. 64 km per hour, as I mentioned. There are many debates around the T90M, particularly about whether its reverse speed remains at 5 km per hour, but there is also information that the automatic gearbox called Malo solved this problem by raising it to 12 to 14 km per hour. If you know anything about it, write in the comments. But in any case, the Merkava has an advantage in scenarios where the tank needs to retreat quickly, which might one day save both the vehicle and the crew. But there is also a downside to the Merkava's power plant. More on that later. An American engine, American-German, and a purely German transmission. This puts production at the mercy of several foreign suppliers. On one hand, this increases repair times and costs, but more interestingly, even a slight change in Israel's political direction could lead to a ban on component supplies. As a result, you'll get approximately what the Russian armed forces are still struggling with Sarmat, despite having the status of a tank-building power and being the direct successor of the Soviet School of Design. In an instant, a modern tank can become a heap of scrap metal, which is concerning, though Israelis don't usually talk about it. The hallmark of the Merkava has always been its running gear, which benefits from the local theater of war. For the first time, Christie suspension with external paired springs and tubular shock absorbers was used in a series-produced tracked vehicle. This solution allowed the full travel of the road wheels to double to 604 mm compared to tanks with torsion bar suspension and greatly increased the free volume inside the hull. The actual effect was comparable to complex hydropneumatics, but much simpler. The first and sixth points are equipped with hydraulic travel stops and the middle points with hydraulic shock absorbers. The spring suspension performed excellently in the region. In 1996, joint exercises were held with the Americans on the M1A1 Abrams. It was concluded that if the Abrams can survive in the Negev desert, they won't last on the Golan Heights. Torsion bars simply crack on the rocks due to limited travel. Meanwhile, Senkase, Washenyomoatebekaise, Isana, Esiganae. The Veterandia springs are much more practical. They can ensure greater travel depth, which is very important when driving on rocks, and they also showed excellent maintainability. If they break, it's easier to replace them in the field. You just need to unscrew a few bolts and replace the units with new ones. However, there turned out to be even more drawbacks. The huge road wheels, even larger than those of the T-55, have very thin rubber, and quite often it had to be replaced in the field. The enormous weight and heat did not spare it either. Some sources claim that the Israelis installed the spring suspension to increase ground clearance to 530 mm, which allegedly reduces the impact of mines on the belly. For comparison, the Abrams has a ground clearance of 432 mm, and the T-72 has 490, so it makes sense torsion bars reduce ground clearance. But in the Mark IV, as I mentioned, an armored plate is welded onto the belly, reducing clearance further to a mere 430 mm. So, no luck here either. But perhaps the most annoying drawback of the spring suspension is that after a sudden stop or shot, the machine with its high center of gravity wobbles for a while, as the springs transmit inertia to each other and then to the hull. So, you have to wait for the wobbles to stop before firing effectively. And this waiting time can be deadly. Nevertheless, if you don't wait for those seconds, the risk of missing the target is high. Equally significant is that the external spring suspension doesn't take hits at all. The running gear elements of the Merkava literally fly apart at the slightest fire impact, unlike torsion bars, which can endure much more. This again immobilizes the tank, making it an easy target. However, during the modernization of the Merkava to the Mk4 level, they tried to address this by redesigning the balance of all support rollers towards the rear. Open-mounted tubular shock absorbers were replaced with blade ones, mounted within the armor. But again, in combat, this changed nothing, as they are still makeshift fixes, and even in Africa, makeshift fixes are still makeshift fixes, only helping to adapt somewhat to the reality. To this end, massive 6-section steel armor screens covering the sides and running gear also help. They are securely attached to special rods and can fold up for access to suspension elements. Overall, I conclude that the mobility of the Merkava has no fewer pitfalls than its protection. All the advantages of the front engine layout literally go down the drain due to the number of drawbacks that negate almost all advantages. Despite having a good engine, what's its use if the weight, poorly protected suspension, and many other nuances will simply lead to the tank losing mobility in practically any moderately serious scenario? Take again the use of the front drive tracked mover, which forced the relocation of side reducers to protruding nose niches. Even being covered with some armor, their gears and bearings, on which the driving wheel axles rest, are extremely sensitive to any structural misalignment. Thus, an explosion of a 420mm high explosive fragmentation shell or a thermobaric grenade from an RPG, Kozim, in front of the tank will also result in loss of mobility, even without penetrating the frontal armor. Yes, the Merkava does a decent job protecting the crew, but what's the point in combat with preserved professionals and huge heaps of immobilized scrap metal? If you have a different opinion, I'd be interested to read it in the comments, but I have presented mine in this video. In the next episode, we'll talk about the firepower of the Merkava, but for now, thanks for watching and see you in the next videos.